I'm going to show you an example of starting with a data set and then calculating the average and then the standard deviation using Excel. So an average should be pretty straightforward. We're talking about the mean average here, which is when we add all the volumes and divide, or add all the numbers in the data set and divide by how many of those there are. Standard deviation is a bit different, and I'll explain that when I get to it. What I've done here is just made up some titration volumes. So let's imagine that you're looking at your chlorine back titration, for example, and you've taken your own final volume that you calculated, and then you've asked all your friends in the class what theirs was, and let's just imagine that these were the numbers they gave. These are nothing close to the reality of that practical. I'm just making the numbers up so that I can show you. So you've collected a data set and you're going to look at the average and then the standard deviation. So the nice thing is that performing these calculations is very quick in Excel. So I'm going to look at taking the average. So I'm just going to click into the cell here where I want the average to appear. Every time I'm going to do a calculation in Excel, I start by typing equals. That means I'm about to tell you to calculate something. And then for average, you just start typing the word average there, open a bracket, and now you're going to highlight all the cells that you want to be included in the average calculation and close the bracket, press enter, and that's going to give you your average there, 14.46. I'm imagining that this is you, for example, this first data set. So taking the average can tell you that when comparing your result to the rest of the class at the whole, your result was close to the average. That might be useful when talking about, sorry, just skipping to the other document, when talking about the repeatability of your measurements. You've compared your results with your classmate, and at least your result is in close agreement with the average. Not so sure about this person here at 9.6, or maybe this person at 16.3, but you could say that your result is in close agreement with the average value across the class. In terms of interpreting that. For the standard deviation, some of you will have done this before, but what this does is it gives a measure of how close all these values in the set are to this average. It gives a measure of, across the group, how close are these values, all of them, to the average. I'm just going to show you first of all actually this data set. So this would never happen, but let's imagine you and all your friends all got 14.5 volumes. To do standard deviation, we're going to do equals. They shorten it to st dev, and you want the P one. Open the brackets, take all of the data in the set and close the brackets. So this is going to give us the standard deviation of 0. So this never happens. A standard deviation of 0 means that these results are all in such tight agreement with the average. They are all the average. They are all absolutely the average value. You can check that, obviously, convince yourself by taking the average of this data set, add them all up, divide them by how many there are, and because they're all the same number, the average is also 14.5, and the standard deviation, how close or how far away each of these values is from the average, is 0, because they are all the average. So obviously that's going to look a bit different here. Equals st.dev .p, open brackets, highlight this, but remember not to include your average value. You only want to do it for the numbers in your data set. So this is giving us a standard deviation of 2.48 or 2.49 rounded from this big long number. It's saying that that's not 0, so these aren't each value is not really tight to the average. But it's not super far away. So in terms of interpreting whatever number you got for this would help you to comment on, again, the repeatability, how your results compare to your classmates, and whether the data set as a whole is in close agreement. The closest agreement would be a standard deviation of 0, and the closer this number is to 0, the better, the more reproducible these results were. And if you get quite a high number here, you could talk about how those results weren't very reproducible and perhaps how that might affect the overall reliability of your analysis. Okay, hope that's helpful. Enjoy.